Good morning, everyone. Am I good to go in the back? Good. All right. Well, good morning, everyone. I'll apologize in advance. I was at a sporting event on Sunday, and I always say you know how good and exciting the game is by how bad your voice is the next day, and my voice is not doing that good. So, lesson learned, not to do that in the future. But at any rate, let's talk how we can reduce our deployment risk with progressive automated canary in a regulated environment. My name is Carlos Martini. I'm a senior cloud architect at Vanguard. If you never heard of Vanguard, that's okay. We don't do a lot of advertising, but we are a multi-trillion-dollar asset management firm. So as you can imagine, we're very heavily regulated. And at the same time, we take that responsibility very seriously. So there's a lot of controls in place before somebody can deploy to production. So as we were trying to implement progressive automated canary, a lot of the challenges we ran into actually had nothing to do with progressive automated canary itself, but just how do we implement a lot of these controls. So I'm kind of hoping, in addition to sharing how to set up progressive automated canary, to also share some of those lessons learned, so that you're able to take that back if you work in a regulated environment such as me. All right, so there's three things that I'm hoping you guys will get out of this presentation. The first one is, why would you even bother using progressive automated canary at all? The second one, I'll show you guys how to set up a very simple pipeline within Spinnaker. And then finally, again, I'll show you guys some strategies within Spinnaker on how to implement some of those regulatory requirements that you might have. All right, before we get started though, there is some assumptions baked into it. It's a 30-minute presentation, so there's only so much that we can cover here, right? So sort of when you go in a ride, you must be this tall. There's a few things that need to take place before you're able to get started on your journey here, right? So the first one is your applications need to have a way to gather metrics, right? So that's good practice outside of this talk, right? You want to be able to debug, get alerts, things like that. On your application, and gathering metrics is a great way to do that. The second one is you really need something set up, whether it be a service mesh or some other way to orchestrate that splitting of traffic, right? So one of the things that we'll learn here for progressive automated canary is you want to be able to send, say 80% of traffic to a specific version of your application, 20% to another version. So you really need some mechanism able to be able to do that. And then finally, the last thing is you really need to have an identity provider set up with Spinnaker, so you really want to limit any kind of access to Spinnaker without knowing who that user is. All right, let's level set a little bit. Lots of buzzwords in there. Progressive automated canary, what does that mean? What is the difference? I'm sure most people have heard of canary in the past, right? So let's try to break that down a little bit, right? So canary, at its most basic level, just implies from sending a canary into a coal mine that you're going to send some percentage of your users to your new version to see whether or not that version actually works as you would expect it to. Canary on its own, it normally implies that some human is doing that verification. So you're either looking at logs, you're going into the application, playing around with it, and deciding whether that's been successful or not. And then the human is also likely pushing some buttons to move traffic around between the different versions. The next evolution of that is automated canary, right? So for automated canary, works pretty much the same way, only you're kind of taking that human element out of it, right? So now a system is the one that is determining whether your new version looks good or not. Your system is the one that's doing the traffic toggling as well. And then finally, progressive really goes to doing the exact same things as automated canary, but it adds one more component, and that is you're slowly ramping up traffic until you get to 100%, right? So with canary, you might just say, I'm going to send half my users there, or maybe 40% of your users, and then if that looks good, then you're switching to 100% right away, right? So it gives you an extra layer of protection there where you're limiting your blast radius should something go wrong to a smaller percentage of your users. So why would you want to use Progressive Automated Canary? Well, in this slide, I'm just kind of showing at a high level some of the other deployment strategies that are out there, right? So at the top, we kind of have the most risky, at the bottom, the less risky, right? So we'll start off with Highlander at the top, which is sort of the most risky deployment strategy you can have, right? So the way that works is you just have your version 1 out there, you deploy your version 2, and right away, all your users are seeing that version 2, right? So you can see the issue there. I'm sure most people have done their due diligence, tests in non-prod, but let's say you have an environment variable that gets set and is different for non-prod versus prod. You have a typo, all of a sudden your application's not working in prod and all your users are affected until you realize you have an issue and either roll back or fix the issue. In the middle, we have blue-green. So blue-green is better than the Highlander, right? So with blue-green, you have your version 1 out there. You deploy your version 2. Version 2 is inactive, meaning your users are still going to version 1. You're able to do some validation, so whether you're looking at logs or you're hitting your application and playing around with it to make sure that it works. So it gives you some level of confidence, right? So in the previous example, if you have an environment variable that had a typo for production, you will be able to see that and your users wouldn't be affected by it. Where blue-green doesn't work as well is, let's say, your application works fine until it comes under load, right? So let's say your application works fine until 40% of your users are hitting it, at which point you start to notice a spike in your latency, right? Blue-green is not really going to be able to help you with that because you won't be able to see that, right? You're only able to do that verification in isolation without any real users. And then finally, at the bottom, you have Progressive Automated Canary. So the way that this will work is you have your version 1, you deploy your version 2, and only a small percentage of your users are hitting your version 2 at first, right? So let's say 10% of your users. You let that run for a little while. You're doing your canary analysis, so now you're comparing the metrics for your version 2 with your version 1. If that looks good, then you're bumping up traffic to your next bump in traffic. But if it doesn't look good, you can automatically roll back, right? So there's a couple of advantages here, right? One is your blast areas is a lot smaller with only 10%. And then the other one is you kind of get that automatic rollback, right? So now if you went out for coffee and that took 10 minutes longer than you expected, by the time you come back, it's already rolled back, right? With some of the other deployment strategies. You might not notice till later, and your users are affected during that time. All right, so let's take a look at how all the different pieces here can work together, right? So on the left-hand side, we have Spinnaker, Cloud Driver is the microservice that's going to do the deployment. You have your application on the right-hand side, right? You have some way to split the traffic, whether it be service mesh or something else, and you also have your metrics store. What's going to happen is you're going to come along, deploy your version 1. That version 1 is going to be collecting metrics. And then let's say 2 weeks later, you come with your canary, you deploy your version 2, and that's also collecting metrics. The key part here is that when you deploy your canary, you do not want to do your comparison to your existing version of production. In other words, you want to do a fresh deploy of your version 1, and that becomes your baseline, and then do the comparison to that baseline as opposed to your version 1. The reason you want to do that is you want to keep your canary and your baseline as close as possible in terms of how they look, right? So let's take an example where you're doing caching for your application, so your version 1 is out there for 2 weeks. By the time the canary comes along, that cache is already pretty filled up, and so that prod version 1 is going to be able to respond a lot faster, right? So when you do your canary analysis, that canary analysis might fail because your canary has a higher latency, but in reality, there's nothing really wrong with it, and if you were to do that canary analysis 2 weeks later, you will likely get a similar result, right? So when you deploy that version 1 again, neither version has the application warm, so you'll get similar results, which is exactly what you would want there. So once you have those 2 versions out there, they're going to be running for some period of time, and then your users are going to come along here, and they're going to get split up between the different versions, right? So let's say you want 10% of your traffic to go to your canary. which means 10% also should go to your baseline, and then 80% to your version that's already in prod. What's going to happen then at that point, Kayenta, which is the Canary Analysis microservice in Spinnaker, is going to pull your metrics from your metric store and do the comparison for your Canary and baseline. And then at that point, it starts to become a repetitive cycle, right? So at that point, either the analysis will pass or fail. If it fails, what it will do is it will switch all traffic, 100% of traffic, back to your prod version 1. But if it doesn't, then it's just going to switch, divert more traffic to your Canary, say 20%. All right, so how do we create a pipeline in Spinnaker? There is a few things that we need to do here. So the first one, as I mentioned, we need to ensure that we have a baseline in Canary deployments. We also want to ensure we have a stage to do that splitting of traffic. Then we also need Canary configs set up, and what this is within Spinnaker, you're able to set which metrics you want to do the comparison on. So if you're using something like Prometheus, for example, you would write your Prometheus query and set that up in Canary configs. Then you also have your Canary Analysis stage. This is a stage that will use the Canary configs to pull the metrics and then do the comparison. So there's some configuration there that you can set up. For instance, how long do you want to run your analysis for, right? And the riskier or the more confident you want to feel, the longer that should be for your change. And then finally, one of the key parts is really that automatic rollback, right? If something goes wrong, this is what actually reduces your risk, right? Without this piece, if the Canary is just allowed to run forever, even though you're reducing your blast areas, you're not able to automatically roll back your users and limit the time that they're actually affected. All right, so let's do demo here. If this screen comes back, awesome. All right, let me zoom out a little bit. So let me set the stage a little bit in terms of what I've done prior to the presentation. So I have a Kubernetes cluster that's running a sample application. Sample application is extremely simple. All it does, it'll either return a 200 or a 500 HTTP status code based on a parameter that I pass in, telling it what percentage should be 200, right? So I've deployed the application. I said 100% of the requests should get a 200. So let's try out the failure scenario first, right? So we'll do a manual start here, and we're going to tell it for this Canary version, let's only have a success rate of 30, right? So it's a 70% difference. This should easily fail our Canary analysis and then roll back to our production version as well. All right. So while that's running, it's going to take a second here. Let's start to look at what the pipeline actually looks like, right? So the stuff in the front we'll cover here in a second. Let's start with our deploying the Canary and deploying baseline. All this is I'm using Kubernetes here in this demo, but all this is basically just a Kubernetes deployment manifest, right? The key part is you want some labels or the naming convention to tell you which version of the application this is, right? So for example, here we're saying this is the Canary. And the reason why this is key is when you go to extract your metrics, you want to be able to keep them separated and filter them out based on whether it's Canary or baseline. Baseline looks exactly the same, only here we're telling it this is the baseline, right? The next stage is we're just telling it to send 10% of the traffic to Canary and baseline. So now for this demo, I'm using Istio with the service mesh. But what I've seen, I've done this with other products as well. It looks pretty much the same in that you're able to say you have some weight and then that's linked to some version of your application, right? So in this case, baseline gets 10%, Canary gets 10%, and your prod ends up getting 80%. All right, we'll come back to the Canary analysis here in a second. The next thing is, once that Canary analysis runs, there's some branching logic to determine did it pass or did it fail. Now, in the scenario that we're running now, it's going to fail, so it'll come into this branch. And then what we want to do is, again, we want to roll back now and say send 100% of the traffic back to the original version 1 that we had there, and then we just want to do a little bit of cleanup where we're deleting the canary and baseline since it failed, or redeploy it once we have a fix for it. All right, so let's take a look here at the failure. So let me expand this a little bit. So what we'll see here is that the canary analysis failed, and then it went into this branch where it failed, it rolled it back, deleted the canary, and deleted the baseline. The other neat thing that Spinnaker has when you're doing canary analysis is this has this good visual representation of your metrics, right? So this is a simple demo, so I only have success rate as a metric, right? But you should, at a minimum, at least have latency along with success rate for your application, right? The other thing that you'll see is that it failed because the canary metric was low, and it was about 70% off, right? So 69%, so that matches what we had in the demo where the previous version was returning 100% of 200s, and the canary only returned 30%. And also has a good visual representation for the time that you did the analysis here as well, right? So your canary and baseline and how many 200s it actually got during that time. All right, so let's try running the success scenario now. So we'll also have 100% success rate on this one, and we'll run it. This one will also take a little while to go. So let's start looking at some of the other stuff we didn't look at before, right? So let's look at the canary analysis and how that's actually set up. So the first thing you'll notice here is this analysis type. When you're running this for real, you will want to do real time. So what this means is like it's actually going to wait the amount of time that you told it to, and then it will look at that time window. It also provides this retrospective option, which is really handy when you're doing demos or when you're actually testing your application. So what retrospective means is instead of looking at the real-time window and when this is running, you're just giving it a time frame where you've already collected metrics, right? So because this takes 30 minutes at a minimum per stage, we don't have that kind of time here. So I ran this in advance, and then it's basically looking at the metrics from the time frame where I ran it. And this is just an if-else statement. Just, you know, if I'm running the failure scenario, use this. If I'm running the success scenario, use that time frame. That's all that is. When you're running this for real, you want to use real time. And the two key things here is how long do you want to run your analysis for? So again, if you want to feel really confident, you'll probably run that for a longer period of time. If it's a low risk change, maybe you run it for less period of time. So this is the lifetime of the entire analysis. There's also this interval field here. So if you want to run, let's say, your final analysis before you switch everybody over for 2 hours, you can also set an interval, say, of 30 minutes, and you're essentially running 4 analysis during that time, right? Like it'll do it every 30 minutes. It will run a new analysis for you, just to make sure that you got your things there. Actually, before I leave, let's talk through the rest of the pipeline, right? So now this is going to go in, it's going to pass for all the different stages, right? As you can see, like, this starts to become pretty repetitive after the first time, right? So again, this is a demo. Another great strategy here might be that you might want to have a rollback pipeline that you invoke from this, right, as opposed to having all this duplication. The other thing that I'll show you guys here is towards the end, right before we switch all the traffic over, I've also set up this manual judgment stage. So again, you don't need to have this, but if your requirements say there needs to be some kind of manual intervention or somebody needs to approve it before you can flip everybody over, this is a great option where the pipeline will actually stop and wait for manual confirmation, and also can send emails and things like that to the right folks that need to approve it. So once it gets past that, at that point, if you kind of have that final confirmation. If you say, no, I don't want to continue, I'll roll it back like everything else. otherwise is going to move forward, right? And the first thing that you want to do there is start to change your labels on your Canary deployment, right? At that point, your Canary becomes your new prod, and so you want to make sure that's being labeled correctly. And then you also want to send 100% of the traffic now to your new prod, right? And you want to delete your old Canary and your old baseline. You want to do some cleanup there as well. All right, so let's go back to our pipeline, which should be stopped, and it is here at this manual stage. So this, again, this comes in pretty handy if you need to do that. So we're going to tell it to continue here, and it will go ahead and flip the Canary to the new version. All right, so I think at this point, this is kind of where we were starting to feel really good about our Canary pipeline. We were excited. It worked pretty well, but I think, you know, we kind of have that new sports car feel, like we just felt like we're going a million miles an hour. It was cool. But then we kind of put on the brakes, right? We're in a regulated environment. We started noticing some things, right? So the first thing was, as we were creating these pipelines, anybody can really do anything and edit those pipelines at will, right? So we needed to have some stages that needed to run for compliance reasons. So for example, we need to create a change record every time something goes to production. Somebody needs to approve that change record. That's not the same developer that coded it and is trying to deploy it. So separation of duties there. So, you know, those type of things can't be removed from the pipeline. The other one that we had was any team can really edit and deploy other teams' codes, right? That was another big no-no, right? Like we wanted to ensure that only teams that owned the code were able to deploy to production. And then finally, the last thing we kind of ran into is we kind of had these complex and custom requirements that we needed to meet that were a little bit difficult to implement with some of the stages that Spinnaker provided. So we really had to figure out like a way that we could do those as well. I think one of the things we learned was, as we started watching, you know, Netflix, a big user of Spinnaker, was that the way some of these non-regulated companies use it is, you know, they kind of have this centralized team, and that team creates stages, and then development teams are able to take those stages and use them in their pipelines, right? Kind of like Lego pieces. They create the Lego pieces, but teams kind of build the pipeline to be what they want it to be. But if you're in a regulated environment, that's kind of risky, right? Like you probably want something where you're kind of building that race car for the teams, and they might be able to customize certain things on it. But at a minimum, you probably want like at least an engine or something in there that teams aren't able to modify, right? It kind of has your regulatory requirements in there. You also probably want to restrict teams from removing stages in that pipeline, and you want to control who can read and execute those pipelines. And then finally, as I mentioned, you might want to have an easy way to execute some of those requirements that don't fit very well within the existing stage types. So I'll show you guys three of the ones that we've decided to use. The first one is what's called the job stage, and that really will help with custom and complex regulatory requirements and might not fit very well within Spinnaker. The next one is pipeline templates. So those are great for ensuring that stages are always being executed and that teams can't remove certain stages that are key. And then finally, we'll talk about the authorization to your apps and pipelines to kind of limit what teams are able to do for different applications. All right, so let me go back here and we'll walk through the actual stages. So as I mentioned, the first one here that I had was creating a change record. So, you know, let's pretend you have this legacy change record system where you can't really call an API, right? You have to do all this complex things behind the scenes in order to get it to work. So the actual setup is actually very simple, right? So you set up this job manifest for your Kubernetes cluster. And essentially, you're giving it an image So that is a custom image that you would create, and then at that point, you're able to run custom code and do whatever you need to do, right? So as you're running that image, you're able to provide any inputs that you might need in order to run your logic. But it's pretty straightforward from a Spinnaker side, right? So this kind of allows you to have that complexity now in code. It can be unit tested, whatever you need to do. And really, the sky is the limit at that point. The really neat thing about this stage, though, is from a Spinnaker perspective, is Spinnaker kind of gives you a first-class setup for handling those outputs, right? So once you run that job stage, you're actually able to output certain variables that you might need to use throughout your pipeline, right? So let's use the change record example where you're creating a change record when the pipeline starts. You might want to close that change record if everything goes well towards the end, so it's not open. This gives you a great way to do that, right? So what you see here, the first line is just a regular log, right? But then Spinnaker will look through the rest of it, and it will look for the Spinnaker property throughout your logs, right? And what it will do is anything after the underscore, so in this example, change number is what I named it, it will turn that into a Spinnaker variable that you can just use right away within your pipeline. So that's kind of like a property one by one. Another option is if you have multiple and you don't want to, essentially have a whole bunch of Spinnaker properties here, is you can also configure the Spinnaker config JSON. The effect is the same, just two ways to do different things, and basically, again, anything here is a key value pair, and it will turn these into variables, right? So then you'll be able to access, a time created later on in your pipeline, as an example. So that's really useful for handling outputs from that. The next thing I'll show you guys is the pipeline templates. So pipeline templates are actually, let me go back here real quick, are very simple, right? So if you don't know, Spinnaker, all these pipelines are essentially just JSON under the covers, right? So the way pipeline templates work is you can actually just build out the pipeline kind of on the UI here, and then you're able to copy and paste this JSON into a pipeline template JSON, which looks almost identical to this. It has a few extra fields, but then it also has a pipeline field, and that's basically a one-to-one mapping to this JSON here. So the really cool thing about the pipeline templates is that users actually aren't able to edit it at all. So let's create a pipeline here. I'm gonna spell that, yeah. From template. And because users are not able to edit anything in that pipeline, so one of the features that Spinnaker provides is parameters for that pipeline, right? So even though you might not want to let them have free range to edit or delete anything in that pipeline, you might want to let them customize certain things, right? So if you want to control how a deployment happens, for example, at a high level, but you still want to allow, say, how many replicas of your application are running, this is a great way to do that, right? So it lets you provide a default value as well, so if users aren't interested in customizing that, they can just take the default values. And the first thing you'll see is manual edits are not allowed. So let's say, I don't want to deal with change record, right? And I try to remove it. It looks like it works. Spinnaker could have better support for this for sure. Like I would expect to see an error there. So it looks like it works, but in reality it doesn't, right? So if I leave the pipeline and then come back to it, the stage is still there. So you can't actually delete or modify anything in here. All right, the last thing I'll show you guys here as we're running out of time is just set up authorizations, and there's really two ways to do that, right? So in here I've set up an application where we have a couple teams. The first one, only team one can read, edit, or execute. And then the other one, other teams are able to read it, but only team one is able to actually execute or edit, right? So the first way is probably the simplest, where you're able to go into the application, go to config, and then under application attributes, you'll see this permission field. And then here, as you're hooked into your identity provider, it will bring back the different groups that user is a part of. So here, for example, we're saying the role of team one will have read, execute, and write. and everyone else can do read. So this works, but it's kind of a pain, right? Because you have to set it up manually, and you have to set it up like application by application. The other option Spinnaker provides, it's a little bit more enterprise ready, I think, in that you're able to, within your configuration for Fiat Local, you're able to set it up for a regular expression. So what this is saying is, prefix, so it's going to look at the application name. You can set this up to whatever you want as a regular expression, right? So in here I set, if it starts with team 1 and then just start, so team 1, application 1, team 1, application 2, et cetera, we're going to set up these defaults, right? So by default, we're going to say nobody will have access to team 1's applications by default. So if team 1 creates an application 2 weeks from now, and as long as we're following that naming convention of team 1, it will inherit these permissions. So you can also add, as you can see, there's a list, so you can have multiple applications, and you can set this up however you need to. And if you need to override it for a certain application, you can do that either here, or if it's just like a one-off, the previous way that I showed you guys. All right. So I think I want you guys to take 3 things away. Why use Progressive Automated Canary? Again, it reduces the risk of downtime for your clients. It reduces the blast area. How do you set up Progressive Automated Canary? I showed you guys a sample pipeline, but I think the key points here are don't compare your canary to what's already out there. Deploy a baseline and compare it to that. Again, you want to make sure you're using the right metrics for your applications, but at a minimum, you want to set up some kind of error success rate and latency. And then finally, how to meet your regulatory requirements. Try to give you guys 3 strategies there: pipeline templates, job stage, and how to set up authorization for your apps. All right, we're at time. I am happy to stick around and answer questions. I will also be around for the remainder of the afternoon and early tomorrow morning. If you see me, feel free to grab me. Feel free to grab me on LinkedIn. I'm happy to answer questions. Thank you, guys.